Hello, let's talk about the solar system today. First, where is the mass in our solar system? The vast majority of it is in the sun. The sun is 99.8% of the mass of the solar system. Then is Jupiter, though. I mean, really small in comparison to the sun, but big compared to all the other stuff. Um, every planet except for Jupiter, including dwarf planets, is 0.04% of the mass, and comets are 0.03%, and everything else is too small to actually get a percentage for. So, really, the most significant parts are the sun and Jupiter. Let's take a look at scale of some objects. So, this here is um, Mercury, Venus, Earth, obviously, and Mars. And this is them in uh to scale with each other. So Venus, you can see, is pretty much almost the same size as the Earth. And Mercury is really small, and Mars is like much smaller than the Earth too. But then let's zoom out. So here are those four that we were looking at, and now here are the gas giant planets. That's what they're called: Jupiter, Saturn, Uranus, and Neptune. All much bigger than the four inner planets, but that's all much smaller than the sun itself. So it makes sense that the sun is the majority of the mass in the solar system. This is also like the biggest thing in the solar system. Let's take a look at the planets. So Mercury is the closest planet to the sun, has a period of 88 Earth days. So it takes 88 Earth days for it to make one orbit. It doesn't have any moons. It has very little atmosphere, and its gravity is 3.7 meters per second squared. So on the Earth, it's 9.8. 3.7 is a lot smaller. Then we have Venus. Venus has a period of 225 Earth days. It doesn't have any moons either. And it has the slowest rotation around its axis, and it rotates in the opposite direction of the Earth. But the one really significant thing about Venus is that it has a hugely thick atmosphere. Surface pressure on Venus is like being 3,000 feet underwater. It's the hottest planetary surface, also, at about 867 degrees Fahrenheit. And gravity is pretty close to on Earth. Like I said, it's pretty close in size, 8.7 meters per second squared. Um, Venus has had a lot of missions gone to it. It's relatively close to the Earth. Mostly flybys, some orbiters, and then some successful landers. But Venus has this super intense atmosphere where the pressure on the surface is like being thousands of feet underwater. Um, so successfully landing a spacecraft on it without that spacecraft like destructing. I don't think that's the right word, but that's okay. Um, it's definitely an accomplishment. So these are photos from, or this is photos from flybys or orbital orbiters. Um, and this is from one of the successful landers taking a picture of itself and the surface of Venus before it like was destroyed by the pressure. And obviously there's no plans to send people to Venus. Um, the pressure is too intense, but maybe eventually they will send rovers. Okay, next up is Earth. I just included it because that's where it is, but we know about Earth. Mars is after that. Its period is read that one. 687 Earth days. So, little less than 2 years. It has two small moons here. It has the highest volcano on any planet in the solar system, Olympus Mons. Has a thin atmosphere, and its gravity is actually like the same as Mercury, 3.7 meters per second squared. There have been a ton of missions to Mars. Flybys, orbiters, landers, rovers. The first rover was Sojourner in 1997. Picture is showing, obviously not on Mars because there's people, but it's showing models of the different Mars rovers. So I believe this one in front is Sojourner. This one is Spirit and Opportunity. Like there's a Spirit and Opportunity version of the same one. And then this one is Curiosity. You can see they definitely scaled up over time. And here is a picture from one of the rovers from the surface of Mars. Actually, I think this is the lander and that's the rover. And NASA is currently working on human missions to Mars. Then in the solar system is the asteroid belt, which is between the orbits of Mars and Jupiter. These four asteroids are the largest ones, and they contain about half of all the mass in the asteroid belt. The total mass of the asteroid belt is only like 4% the mass of the moon. And it's all material that never formed into a planet, most likely because of gravitational perturbations or small changes caused by Jupiter. Jupiter is close to it, and Jupiter, like I said, has a significant mass in the solar system. There's tons of objects in the asteroid belt, but it's still very much mostly empty space. Jupiter, largest planet, it has a period of 12 years. It's 300 times the mass of the Earth. Its gravity is pretty significant, 24.79 meters per second squared. It has 79 known moons. 5.2 AU. AU is astronomical units. It just means the Earth's distance from the sun. So it's 5.2 times the Earth's distance from the sun. A day on Jupiter is 10 hours. And a day is what the rotation of the planet. So it rotates on its axis every 10 hours. And the red spot is a storm that's been going for a long time. I don't want to put a specific number on. I mean, at least decades, but I think probably longer than that. And it's larger than the Earth. So imagine that, a storm bigger than the Earth. Saturn is the second largest planet. Its period is 30 years. It's 95 times the mass of the Earth. Its gravity is actually pretty close to the Earth's gravity, 10.44 meters per second squared. It has 62 known moons, 10 times the orbit, 10 times the distance from the sun that the Earth is. Its days are 10.7 hours, so it spins around real quick, and it obviously has prominent rings. And then there's Uranus. Its period is 84 years. It's 15 times the mass of the Earth. The gravity is actually less than the Earth, 8.69 meters per second squared. Has 27 known moons. It's 19 times farther away from the sun than the Earth is. Its day is 17 hours, and it rotates on its side, which is interesting. Neptune has a period of 165 years. That's how long it takes it to get around the sun. 17 times the mass of the Earth, but gravitational acceleration is just 11.15 meters per second squared. It has 14 known moons, and it's 30 times farther away from the sun than the Earth is. A day is 16 hours, and sometimes Pluto is closer than it because there's a little overlap in their orbits. Speaking of Pluto, Pluto is a dwarf planet, not actually a planet anymore. It has a period of 248 years. It is a tiny, tiny mass. It's much less massive than the Earth. About not even 1 meter per second squared gravitational acceleration on the surface, but it has 5 known moons. And it's 40 times the farther away from the sun than the Earth is. But like I said, it crosses with Neptune's orbit. It's because it has a very like elliptical orbit. So it goes from like 30 to 50 times the distance from the sun that the Earth is. And And its day is 6 Earth days, so it spins on its axis pretty slowly. And its largest moon, I'm going to try and remember how to pronounce it. I think it's pronounced Chiron. Um, and it's so large that they are actually orbiting each other, which technically is always the case, but like it actually really makes Pluto move around. Let's talk moons a little bit. I'm mainly just going to focus on the most interesting ones, and that is fully my biased opinion of what makes them interesting. So 4 largest moons of Jupiter. These are called the Galilean moons because they were discovered by Galileo in the 1600s. Somebody else probably could have discovered them before then, but Galileo gets the credit. So there's Ganymede, Io, Europa, and Callisto. Ganymede is the largest moon in the solar system. It's bigger than Mercury, but not as massive. And its gravity is 1.4 meters per second squared. There's likely an ocean below the surface with potential for life. Um, so here's this down here is a diagram of what we think the interior of Ganymede looks like. So under the icy crust, it's proposed that there is a large saltwater ocean, then a thick layer of ice, a rocky mantle, and a liquid iron core surrounding a solid iron core. There's a lot of complicated ways to determine what the interior of a planet, moon, or asteroid is. And some of that is the density of the object. So comparing the size to the mass through gravitational interactions. So for one thing, it's bigger than Mercury, but less massive and has less gravity than Mercury. So it makes sense that there would be something like a layer of water in there, instead of just like all different kinds of rock all the way down. Um, some of how you determine what the interior might look like also has to do with surface features that indicate liquid water layer below the surface. Um, and some also have to do with magnetic fields. Callisto is the second largest moon of Jupiter, third largest in the solar system. It's nearly the size of Mercury, but much less massive than Mercury. 1.2 meters per second squared for acceleration due to gravity. And again, also likely ocean below the surface with a potential for life. So here's what the model of the interior of Callisto looks like. So we have ice, then we have a saltwater ocean and more ice, rocks and ice, and then a rock and metal core. Io is the next one. Io is the highest density moon, and it's the most geologically active object in the solar system. Its gravity is 1.8 meters per second squared. So it has a thin crust, molten mantle, and then an iron core. And what makes Io so geologically active is tidal heating. And this is caused by an interaction between Jupiter and the other Galilean moons, along with the fact that Io's orbit has more eccentricity, more of an elliptical orbit. So sometimes Io is closer to Jupiter, and the gravity of Jupiter stretches the moon out. So when it's closer to Jupiter, it stretches it out. And when it's farther away, it kind of squishes back in. And this stretching and squishing causes the intense geological activity on that moon. And you can see this is an image of an eruption on Io. So that eruption is gigantic. Can you imagine that on the Earth? That might be like what killed the dinosaurs. I mean, not an eruption, but the scale of it is massive. Then Europa has a gravity of 1.3 meters per second squared, liquid subsurface oceans, and it is geologically active also from tidal heating, although obviously much less extreme than Io's. And it's actually one of the most likely places for life in the solar system. And a couple of things, these kind of weird like lines and marks on the surface are part of what indicates that it has a subsurface ocean, because that's just an ice covering. And then um, part of why it is one of the most likely places for life on in the solar system is because it's geologically active, and that adds energy into that subsurface ocean, increasing the likelihood for life to form. Um, and we base our understanding of what is needed for life on what we see on Earth, right? So, as far as we know, what is needed for life is liquid water and energy. And so, liquid water in the subsurface ocean and energy caused by geological activity. So, now moving on to moons of Saturn. This is Enceladus. It also has a below surface ocean, and you can see this like weird wrinkliness, which is characteristic of the ocean and the ice crust above it. Um, and it also has potential for life because it has the ocean, and then it also has these active jets. And actually, these jets that Enceladus have make a huge mess. It makes this whole part of the ring around one of like just part of Saturn's rings. It's all just um, from material sent up through these jets. Um, and it's believed that they originate below the ocean's surface due to tidal heating again. They push material up through the ocean and through the icy crust. And then, yeah, they formed an additional ring around Saturn. Okay, last one we're going to talk about is Titan. Titan is also a moon of Saturn. It's the second largest moon in the solar system. It has a dense nitrogen atmosphere and liquid methane lakes. It's the only known moon with a dense atmosphere and the only other object in the solar system to have liquid on its surface, known to have liquid on its surface. It's also the first moon of another planet that has had spacecraft land on it. So we have pictures from the surface of Titan here, from the lander, and the liquid methane lakes, which you can also kind of see here. And then this is actually a true color image of the atmospheric layers. And NASA is planning a mission to Titan in 2028. It was originally supposed to be this year, but they pushed it back. So we'll see. But that's all I've got for you. There's your introduction to the solar system, mostly based on what I think is cool.